Hello, this is Bijoy. Welcome to our channel, and today we are going to show you this June 2017 problem of the booklet code B and question number 62. Let me show you the problem. This problem is on the topic digital electronics, and it employs some gates and other components uh, to to generate this problem. This problem says it in the figures below. X and Y are 1 bit inputs, and the circuit which corresponds to a 1 bit comparator is, as you can see, this question here. It has four options. The four options, each one of them has a circuit drawn, and you have to find the circuit that best, one and only of them will match the conditions specified in the question. So I have drawn the first option here in this place, and I will show you how to solve this problem. So before checking the options, I will explain what is a comparator, and how to understand the options given in this problem. So we take the example of the first option given here to understand the comparator circuit. So here you can see there are two inputs x and y, and there are three outputs x, x less than y, x equal to y, and x greater than y. As many of you can already guess that these circuits will have inputs and then produce some output based on the inputs. So what is the logic of the outputs? Let's understand. This x and y are 1 bit input, so we can give any value of the two values 0 and 1 to these inputs. That is, x can be either 0 or 1, and y also can be either 0 or 1. When we put x equal to 0 and y equal to 0, they form one combination of input. Similarly, when we put x equal to 0 and y equal to 1, it forms another combination. We have to put all the different combinations here and see whether this output are generating the expected output or not. So to be a comparator, this inputs when these inputs are same, this x equal to y output point wire terminal should give you 1 to indicate that the two inputs are equal. If x or y, someone of them, any one of them is less, that is, if x is 0 and y is 1, then we will say that x is less than y. In that case, this x less than y terminal should give us 1 to indicate that x is less than y. Similarly, when this y is 0 and x is 1, then this third terminal should give us 1 to indicate this. And it is to be noted that when one input gives 1, other two inputs should give 0. So that's the concept of comparator in this case, and we will check this option first option now, to see whether this circuit acts as a comparator or not. So we'll apply the different combinations of the inputs x and y and check. So the first input combination is 0 and 0. So the 0 and 0 that we are putting here, the value of x from starts from here and goes to starts from here. We put 0 here. It goes here and becomes 1. As you can see, there is a NOT gate. This y is also 0. It goes directly here and it remains 0 because there is no NOT or some other gate in the path. This here x wire, it is coming from here. You can see it remains 0 here, and y wire, as you can see, it is going here and coming at this point, so it remains 0 here also. Now this AND gate that you can see, this AND gate will take this 1 and 0 as inputs and produce 0 according to the Boolean algebra, and similarly this NOT AND gate will produce 0 here also. These two outputs from these two AND gates now are going from this wire and these forward circuits. So from here we are getting 0 final output. From here, this 0 and 0 are going to this OR gate and producing 0, and in the third output also we are getting 0, just because this is directly coming from this area, this line. So in the case where 0 and 0, x and y both are 0, this output x equal to y should give us 1. But unfortunately it is not giving, so we will say that this option is not the correct answer. Now we will go and check the second option. I have already drawn it for you. To check this option, we'll put the same values again, x and y. Let's put 0 and 0, and whether check we'll check whether they are satisfying the comparator condition or not. So x is we are putting 0, and it is reaching here as 1 because there is a NOT gate in the path. Similarly, this y here we are putting 0, and it remains 0 here. There is no NOT gate, and this wire comes from the x input, so it remains 0. This wire goes to this place, it remains 0 because y is 0. Now this AND gate will produce 0 just because 0 and 1 becomes 0. Similarly, this will also produce 0. So in this case also we are getting 0 here. Here also you're getting 0, and here also you're getting 0. So this option 2, is also not the correct answer. So we have to ignore it. Now it's time to see the third option. Actually, we have to draw it. I will draw it for you. So this third option that you can see here, let me draw it for you. This option has two inputs, x and y. X you can see here, and this x goes through a NOT gate like this. This NOT gate goes forward, and the output goes forward. Similarly, there is another line from here we draw. Actually, let's draw the other input also, y. This input goes like this, and let me draw it. There is an AND gate. Here the final outputs from these inputs goes through another gate, one OR gate. Actually, it is a NOR gate. There is a bubble in the right side, and the output is x equal to 1, y. This output is x less than y, and this output is x greater than y. Yeah, so this is the option. Now let us check this also for the input combination. Let's draw this combinations. The first combination is the first combination is 0 0, that you can see. The 0 goes from here, and y also goes 0, so 0 goes inside. Here, after passing through the NOT gate, it becomes 1, and here in this y also here passes and it becomes 1. Yes, so this in this terminal you get 1, in this terminal you get 1, but this wire goes here, and here you get 0, and here also you get 0 from the x line. Now when we this inputs passes through the AND gate, it remains it becomes 0 because 1 dot 0 equal to 0, and here also you get 0 similarly. And this output from after going from here produces it 0. It is also 0, but here you can see the 0 and 0 goes through the OR gate, it remains 0, but after this bubble it becomes 1. So here you can see when x and y both are 0, we are getting this x equal to y terminal to 1. That means this input combination is properly handled by the comparator circuit. Now let's check the second combination possible, that is 0 1. In this case, here we are putting uh, putting 1 instead of 0. Let me just erase the previous values. So here this output this here in this place you get 1. Here also you get 1 because this y goes there. Here you get 0, here you get 0. This gate 0 0 will produce 0 here, and this 1 1 will produce 1 here. 1. As you can see, this 1 goes directly to the output here, so x less than y terminal becomes 1, and this 1 coming here in this OR gate, 0 also going in the same gate, so it will produce 1 and this bubble will produce 0. And here this 0 goes directly to this place output, so it remains 0. So in this case, when you can see x is 0 and y is 1, that is x is less than y, then this x less than y terminal produces 1 and other two terminals produces 0. So this value combination is also properly handled by the comparator. Now this next combination we are going to check is 1 and 0. This 1 and 0 uh, combination we need to check. So let's just remove the previous values. These previous values I have removed. Now let's check. This x is 1 and y is 0. So what happens, this 1 goes from this NOT gate and it becomes 0. Here this y goes here and remains 0. This it becomes 1 after passing through the or NOT gate, and here we get 1. So in this case this 1 1 gives 1 here, this 0 0 gives 0 here. So this 0 and 1, you see that this 0 is going here as output. This 0 and this 1 goes here. After the OR combination it becomes 1, and after the bubble it becomes 0. And here you get 1 as output. So in this case you get 0 in the first output terminal, 0 in the second output terminal, and 1 in the third output terminal. So this 1 says that x is greater than y, and in the input combination also you see x is greater than y. So the third combination is also satisfied by this comparator. Now the last value that we need to see is 1 1. So let's modify this, remove this previous values. Let's put these values 1 and 1 here. After passing through this NOT gate it becomes 0. Here we get 0, here you get 1, here also you get 1. In this case this AND gate will produce 0 here because the own one of the inputs is 0, and here also you get 0. This causes this output terminal to give 0, this output terminal gives 0, and this terminal, this OR gate will produce 0, but this bubble will cause it to change to 1. So in this case also you get the same the result, expected result, that is x and y you see are equal, and this x equal to y terminal gives 1 and all the other terminals give 0. So we'll say that this third combination is also being handled by this comparator properly, and that means this option 3 is the right answer. So we reach to the conclusion that the answer to this question is the option 3. So that's the solution. Stay tuned for more problems to our channel. Thank you.